up to GitHub. So up in GitHub, we can send as many beers across the table as we want. That's great. Something you'll notice is that they will go over the head of the player there. So that's where we need to set up some things to make a little bit more sense in terms of like how they appear visually. We're going to set that up really quick, and we're just going to make a bunch of node 2Ds. So the first node 2D, background. The next node 2D, actually, that's called background. We're going to put the background in that. Easy. Let's go to 2D view here. So the background is going to be in the background node 2D. Do anything with that when we want to. And then we're going to add another node 2D. And we're using these as like visual groupings. So the next is going to be patrons. And so then we put all the patrons in that. They're layered properly. So the way things will appear visually will be based on the topmost is the furthest behind. And so what's happening is when we spawn a drink in, it's going in front of, like below bartender here. And so it's going to get displayed over top of bartender. What we need to do is now add in another layer, another node 2D as a grouping, and put this as bar top. So the bar top will always have the bar on the very bottom. But now that we have that bar top, tap will also go in bar top and be over the bar. And so what'll happen is, like, let's say I move this all the way to the front, it'll cover up him there. Or if I move the patrons, there, they'll show up above that. So it makes it really easy to have these groupings of things. And so I want that spawn point to be the same on the bar top as well. So we're going to put the marker 2D, the drink spawn point, in the bar top grouping as well, because then if we decide to like move the bar top, the spawn point will go with it, which is cool. And for these groupings, we're not too concerned with where their origin is, just because it's mostly to have them like visually placed. We can figure out the origin later if we really want to, but I doubt we'll need to for this game. And then on the bar top, when we spawn a new drink in, we'll add the child into the bar top. And so what we want to do here is we'll add another node 2D inside the bar top to be drinks. Whenever we spawn a drink in, we can then assign it to drinks as a child. So we go into our script here, and instead of adding child to playground, we can either do this direct reference to it, or drag, hold control, boom, we've got drinks. Don't want to say layer. Yeah, let's say layer for now. So drinks layer, we're gonna have that as a reference there. Drinks layer, add child drink. So now the drinks will just appear in that drinks layer and should, in theory, be between the player and the bar visually. And then the bartender will just add another node 2D layer in here. And we'll just put it on like bartender layer. With all of those changes, because we said the drinks will be added as a child on the drinks layer, which is this right here, bar top drinks, should see those beers go behind the bartender's head now, and we have an error. The drink spawn point has moved because we moved it in the tree, so that's why it's good to do this. The error only occurs in one spot, so I only have to change it once. So what we'll do here is actually delete that and drag this back in for its reference. Replay. There we go. The drinks go behind the bartender's head, but in front of the patrons as well as in front of the bar top. So there you go. We fixed some visual stuff. Let's go ahead and put that up to GitHub as well. With that pushed up to GitHub, we want to tackle the next thing. So we have as many drinks as we want flying across the bar. Something that we want to tweak in terms of like how it feels and everything is the friction. Or the drag of the beer going across the bar. I want it to be, at least for now, when we give an impulse of 100, actually, let's say we give an impulse of 80 that the, the, the drink will stop at the end of the bar here. We need to figure out from this marker point to here is, let's say like to about here, make it a nice even number, 590, let's make it just 600 pixels, is 600 pixels. So we want the drink, when given an impulse of 80%, to stop right here after 600 pixels of travel. So we're going to do this. We're going to put in 80 as the impulse here. And see what that looks like. So 80 represents like the 80% impulse for us. Click, and that will slide for a bit, and it's probably going to just go off screen because we don't really have the drag or the friction or anything like that defined. That's really close already. Just happened to be that way. But what we can do is we go into the drink here, and if we look at friction, let's try and understand what friction does. We're in physics material, so we need to actually look at the physics material documentation. So you can search in here, physics material, friction, no idea what that means in terms of what we want to do. And because it's not really interacting with anything like with physics, it makes me wonder if we turn it to 0, will the drink, so on process, we'll just have the drink print its velocity, its linear velocity. And we'll just see if the friction was actually what was slowing it down. It is not. The friction is not what was slowing it down. For some reason, our drink is slowing down on its own. We don't quite know why. If we turn the friction up to like, can we turn it up to 10? I think it said 1 is maximum friction, so it shouldn't matter. So it looks like the friction isn't what's impacting the slowdown. So we're gonna look at all of this. Center mass is auto. Yeah, all of this damp mode. If we set it to replace linear damp mode, let's see. This is my first time dealing with this, so we're learning this together. Okay, so we replaced the linear damping, which makes it so the beer doesn't slow down. So there was some sort of damping going on with the environment that was adding to the damping for some reason. Yeah, so combine in this mode, damping value is added to any value set in areas or the default value. We have our velocity of our 80 right there. And over 600 pixels, we want it to slow down to nothing. Ah, that's where it was. Physics 2D default linear damp. So if we go to project settings, 2D, we're going to go, 3D, 2D, we're going to go to physics 2D, default linear damp is 0.1. So that's what that was doing there. So we're actually going to put that down to 0. That way we don't have to say replace for the damping mode, which gives us the option to later add in things like if we really wanted to, like a water slick that makes it frictionless or go faster or something like that. It just future-proofs us a little bit. So now with that back on combine and the project settings set to 0 linear damping, we don't see it slow down here, which is great. That's exactly what we want. What we do want, though, is to see how fast a damping of like 80 would slow us down. A deceleration value of 80 per second. In theory, if we give an impulse of 80, it'll get reduced to 0 in a second if my math is correct. It might not be, but we'll see. Okay, that went to 0 immediately. Maybe it's a lot different than that. So that means it might be, in theory, 80 every frame. So every physics frame is roughly like every 60 frames. Bring it down to a damping of 1 and see what happens. Looks like the damping is more of like a percentage. So this is where we don't really want to deal with damping then. What we actually want to deal with is in the process of the drink, we want to process like the friction and stuff like that. So there's a couple options. if we want to add in like a friction layer, we can do that. We can make it so that like the beer can like interact with the table and all that. Let's try that first. Let's go ahead and add in, we're going to create a new scene. Let's actually check our changes really quick in GitHub. Looking at this, yeah, we're going to just put this up to GitHub really quick. Okay, with that up to GitHub is removing the linear damping. We just wanted to put that up there real quick. We're going to go ahead and make, since we're getting to like a new chunk, we're going to make the bar into its own scene so that it can have like collision shapes and stuff. Actually, no, as a quick proof of concept, we're just going to add a child in here as a, yeah, we got to make it its own scene. So we're going to make its own scene, bar, go in here. We're going to change the type just like we did before. We're going to make the bar a static body 2D, which is something that can be interacted with in physics, but it really doesn't like move around in physics in itself. So like, for example, the rigid body 2D is the drink that can tumble around, blah, 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 be spun and all that. Whereas the static body 2D is something that won't move. It's like a wall. That's what we're trying to do there. And that's kind of exactly what we want the bar to be. We want it to be basically a floor that the drink slides on. And so we're going to add back in here the sprite. So I'll go to 2D. We'll remember the transform of 320 by 180, and we'll actually reset that 320, 180. Save all these things. Boom, it's gone, but that's okay. It'll come back. Put that in 320, 180. We're good. We go to the bar here, and we add that bar sprite back in. This bar sprite we're going to make sure is back at 0, 0, so that our bar is back. So we have our nice restructured bar, but it needs a collision shape because we're going to put a collision shape on the bar so that the beer slides as we want it to. And that'll allow us to actually have like the beer fall off the end if we want to, which would be really neat. Start with this. So I'll add a child, a collision shape. We can just add a rectangle. We're going to make this rectangle 360 long. And where does the drink actually end up? Just try out. So the drink's bottom is 17 pixels from the bottom of the bar, so we need the collision shape to be 17 tall would be the easiest. It's 40 long, my bad. 17 in the Y direction, and then we actually move the collision shape down. And like I said before, the dots can be a little weird, so you've got to, I guess it doesn't need to be exactly 17. What we'll do is, yeah, we'll just make it like that. Let's see what happens. So you need to also add the bar to be on collision layer 1 because we're not really doing a whole lot of other collision layers. So things will collide with the bar on layer 1 if they are looking for it, and then the drink is also on layer 1 and will collide with it, and we'll just take the drink out of any collision layers. We don't want drinks hitting each other because that's what was happening earlier when we saw like the jitteriness when they were too close together. So in theory, bar now has that shape. We will extend this collision shape up by a pixel. Looks like that should be okay. Sometimes the pixels are a little weird in display here, but let's see what happens. And then we actually need to add gravity back into the drink. So in theory, the drink will slide across the top. Yeah, that's really funny. So we have the friction set to 1, and that means, what if we set the friction of the glass to 0, of the drink to 0? And then the bar is what defines the friction. So now the bar might, oh yeah, so this is where the rough function comes in. The bar is going to be rough. Oh yeah, we have to add in the physics material to the bar. It has a friction of 1, and so we should see the drink fall over. Oh, no, it won't, because we need the bar to be rough. Okay, so the engine uses the lowest friction. So we're going to put rough on both of these, and we're going to make the drink 0 friction. And then the drink falls over again, which is really funny. But let's try putting it to like 0.5 friction. Restart. So it stops really fast. Let's put it to like 0.1 for friction. So that is working pretty well. We just need to figure out like if that's worth it, or if we just put a deceleration on the drink. And I think that's what we want to do because we're not doing any like crazy physics simulation here. We'll put the bar to like 1 friction. It doesn't really need physics material. And we're really discovering here that we don't actually need any of those changes for the bar. So this is a good lesson in using GitHub to sort of just revert things that you don't really necessarily need. So the bar.tscene and playground and drink, all of these changes since we last pushed it up are right there. Everything we just did, we're just going to get rid of it. Right click on 3 changed files, discard all changes, discard all of them. Then we'll go into Godot. It'll say that we have some like changes that need to be reloaded and all that. So we'll not save and reload the project. And now that we're back in here, the game should function as we had it before. So we did some exploration, didn't really work out. We figured out that we actually do want to make it so that there's no like physics damping or drag on it. And we just want to incorporate our own like drag system into the rigid body 2D. So what we can do in here then is add a variable of drag, and this is basically going to be a deceleration. So our drag is going to equal, let's say, 80, and that is just going to be in pixels per second per second. So we're going to decelerate at a rate of 80 pixels per second per second. So if we send it out at 80 pixels per second, which is what we do in playground here, then it should decelerate to 0 after 1 second of travel. Once we implement into the physics process, so every physics object has a function for physics process. Processes differently than regular process. It processes on the physics frames, which just makes sure that things are aligned properly. Since we're affecting like the linear velocity and stuff, that's where we're going to want to do this sort of deceleration manually. So we're going to want to apply, I believe, a force on this actually. Yeah, so we're going to apply a force every physics update that is going to be, oh yeah, so we actually need this to be a vector 2. So our drag is going to be a vector 2 of minus 80, 80 as the value, and we can turn it into a minus or a plus based on the direction. We only care about the absolute value of the drag. And then we're going to go ahead and apply a force. We'll make the drag negative because in this case we're going positive and it's simplify it for the game. We're going to apply a force of drag, but it's meant to be applied every physics update, and physics update has a delta. Delta increases in value every physics frame, and it usually goes every single physics frame. But if it ever skips a physics frame, delta will be increased so that you don't fall out of sync with the physics process. So what we do then is we say drag times delta, and we apply that force every physics frame. So in theory, every second we'll apply a total drag force of minus 80 in the x. And it is not working as expected in any way. So since that's not behaving as expected whatsoever, we'll go back in. We'll just try removing delta, see what happens, because it may be automatically dividing it for us. That's really funny to see that the beer fly off the left because we need to say if linear velocity dot x is greater than 0, that's the only time we apply the drag. So in theory, got 1/1000. Boom. It's basically what we expected there, where it brings it down to what we wanted. If the linear velocity dot x is greater than 0, we want it to be applying the drag. Otherwise, we want the linear velocity x to equal 0, just so we don't have any like ghost velocity going on there. That actually did work somewhat as expected in the sense that we slowed down from an impulse of 80 pixels to 0 in 1 second. We'll have to come back to it, old dog stuff.